Hello, my fellow mathematician. Welcome to the study of analytic function. Uh, we are considering complex functions, and a necessary and sufficient condition for this function to be analytic is that in both function u, and v should be together with their partial derivative must be continuous and differentiable inside and on the boundary of their definition. And also they should satisfy what is called Cauchy-Riemann equation. We normally call them CR equation. So I repeat, in order for analytical function, this one to be, in order for a function to be analytical, a necessary and sufficient condition is that the function u, note that here u is a function of x and y, and also v is equal to a function of x and y. So in order for this function to be analytical, it must satisfy what is called CR. CR stands for Cauchy-Riemann equations. And the number 2, both function u and v, together with their partial derivative, they must be continuous inside and on the inside and on the boundary of their definition. Now, a function is continuous if the limit exists. And if the limit exists, then a function is differentiable. So a function is continuous if the limit exists. And if the limit exists, then a function is differentiable. Now, so for the complex number, a function f of z is analytical if u and v, together with their partial derivative, are continuous and differentiable inside and on the boundary of their differentiation. And also if they satisfy what is called Cauchy-Riemann equations. Now, Cauchy-Riemann equations are the following. Cauchy-Riemann equation tells us that the partial of u with respect to x must be equal to the partial of v, partial derivative of v with respect to y. And at the same time, partial derivative of u with respect to y must be equal to negative of partial derivative of v with respect to x. So these equations are what is referred to as Cauchy-Riemann equation, or in short, CR equations. Simply, partial derivative of u with respect to x is equal to partial derivative of v with respect to y, and the partial derivative of u with respect to y is equal to negative of partial and derivative of v with respect to x. So these are what is referred to as a Cauchy-Riemann equation. Now the next thing, what I want to do here is to show, we are going to show that, we are supposed to show that this function f of z is equal to exponential z is analytic everywhere in the complex plane. So to do this is very simple. First of all, you note that z is a function of x plus I, y. So f of z can be written as exponential x plus iy. By laws of indices, this can be written as exponential I or exponential x multiplied by exponential iy. Then from there, by what is called Euler formula, this part here, we can write it as exponential iy multiplied by exponential x. So by Euler's formula, exponential iy is equal to cos of y plus I sine of y, meaning that our function of f of z can be written as exponential x into bracket cos of y plus I sine of y. So this is by Euler's formula. On more on how to do with Euler's formula, check on my previous YouTube channel, and you are going to see the study. Then from here, we break this down. We write u, whereby u is a function of x and y. In our case, it will be exponential x cos of y, and then from there we get the partial derivative of u with respect to x, which in this case will be exponential x cos of y. At the same time also we get partial derivative of u with respect to y. When we differentiate this, we are going to get negative exponential x sine of y, differentiating cos y will give us sine of y. Then from there we also write v by noting v is equal to a function of x and y, and in our case it is equal to exponential x sine of y. Then we get partial of v with respect to y, which is equal to exponential x cos of y. Then we get partial of v with respect to x, which is equal to exponential x sine of y. Once now we have obtained our four partial derivative, we make use of Cauchy-Riemann equation. We compare partial of u with respect to x. We see whether it is equal to partial of v with respect to y. Now in our case here, you can see partial of u with respect to x is exponential x cos of y. Then partial of v with respect to y is equal to exponential x cos of y. So this equation has been satisfied. We also check the other equation, which tells us that the partial of u with respect to y should be equal to negative partial of v with respect to x. Here we have negative exponential x sine of y, and here we have exponential x sine of y, meaning that our f of z, we say f of z satisfies Cauchy-Riemann equation. Therefore, it is an analytic function. So f of z, which you are given as f of z is equal to exponential z, is an analytic function everywhere on the complex plane. So thanks so much for taking your time to study with me on Introduction to Analytic Function. On more such equations, kindly turn on to my YouTube channel so that we may keep on learning together. Bye bye. See you in the next study.